Okay, so last time we did 1.5 and 1.6 kind of mushed together. Today we're kind of doing the same thing with 1.7, 1.8. We kind of already talked about some of these concepts, but now we're just kind of bringing them all together. Okay, so inequalities. So just kind of the most important thing to remember, guys, when you're doing inequalities is that you flip the sign whenever you are doing multiplying or dividing by a negative. So don't forget that you flip the sign when you multiply or divide by a negative. Okay, so that's like the most key thing to remember. So whenever you are doing adding, subtracting, negatives, don't worry about the sign flipping. It's only when you multiply or divide by a negative. Okay, so I'm gonna take you through a couple of examples just so you guys can see what I'm talking about. So like right here, number one, we solve it just like we would normally solve it, right? We add two to both sides. We get x is greater than or equal to negative 20. That's a plus two. Okay. Since I did not multiply or divide by a negative, I just leave it alone. That's it. Now, right here, this would be it. I'd be done. Now let's take two for instance. We add 16 to both sides. Okay, we get this 46. Okay, but now we still need to get x by itself, so we divide by negative 2, divide by negative 2. Now, because we divided by negative 2, we have to flip the sign. So now we get 23. Well, sorry, negative 23. Okay, and then this one kind of goes through the process as well. Okay, so on the inequalities, guys, it's solving for x, solving for y. It's almost identical to what we've been doing. Just we're adding this notion of greater than, less than. All right. Now, when we're graphing it, it does play. There's some important roles that these play. Okay. So one thing is when we are graphing um, less than or equal to, the dot that we choose has to be filled in when it says equal to. Okay. Same thing with greater than. All right. Now, if we're graphing a line, it has to be a solid line. A solid line. Okay. So if we're doing a graph, but if it's just greater than or less than, this would be an open circle or a dotted line. Okay. Open circle or a dotted line, just depending on the graph. So something that looks like this would look like this. So like if it was greater than or equal to, it would look like this. And say if it was greater, we would shade the top, okay, but with a dotted line. Now, if it was equal to, then we would have a solid line. And if it was greater than, then we include everything above it. Okay, so that's kind of just the only difference. All right. Oh, okay, right here. Here, so here's a couple of examples. So let's do this one. So um, let's solve for x. So we add 7 to both sides. So now we have negative 3x is less than negative 12. Divide by negative 3, divide by negative 3. Because we divide by negative, the sign flips. So look, it's going this way. It says x is less than. So now is x is greater than. And this would be 4. And to graph it, all we do is we kind of just put the hash mark, put it at 4. It's not equal to, so we leave it open. It's an open circle. And x is greater than 4. So where's greater? Is greater 5 or is greater 3? Okay, greater is 5, right? So we just make the arrow going this way. And we shade in the arrow. Okay. So number 2, plus 3 plus 3. So we get negative 4x is less than 16. Divide by a negative, divide by a negative 4. So we have to flip the sign. And again, we start at -4, but the no hash mark. X is greater than -4. So what's greater, -3 or -5? And -3 is greater. So we shade, okay? Now, what happens if we have an X on both sides? The process is the same, guys. It's very similar to what we've been doing. All right, pick a side and put the X's on one side and then the numbers on the other. Um, I'm gonna go ahead and start with number 4. I'm gonna move the 9X here, but at the same time, I'm gonna move the 60 to the other side. Okay, so I'm doing 2 moves in one. I'm trying to save time and paper. So these cancel and these cancel. So 60 minus 14 would give me 46. And then 45 minus 9 gives us 36. Okay. Not done yet. I got to divide. I got to divide. So now I get 46 divided by 36 is less than X. Now I could reduce this. This could be reduced by half actually. So 20 could be 23 over 18. Yeah, 18. Okay. So over here, what do we do first? We could distribute or however you want to do it. So that's what I like to do. I like to distribute. Okay, 3x, 18, 4 plus x. Pick a side. In this case, I want to put my x's on the left. So I'm going to move this one to the left. And then this plus 18, I'm moving it to the right. Okay, I'm doing 2 steps in one. So this will cancel and this will cancel. So 3x minus x is 2x. 4 plus 18 is 22. Divide by 2, divide by 2. X is less than 11. Okay. So there's several ways of doing this, guys. So by all means, whatever fits your style, right? Um, okay. So I could have easily moved the x the other way. I could have easily moved the 3x this way and still done the same process, but I would still get the same answer. Okay. Now, right here, I like to distribute, so I'm going to have 1/3 x. 1/3 times -3 is actually just -1, and 12 plus x. Okay. Uh, here, I don't like to have 1/3, right? I don't like that. So what I'm going to do is I'm going to multiply every single number by 3. And this way, I'm going to get rid of my fraction. So this and this will cancel, leaving me just x. 3 times 1 is -3. 3 times 12 is 36. 3 times x is 3x. Okay. Now, I pick a side. I can pick to the left, I can pick to the right, it doesn't matter. Okay. I'm gonna pick the left, so I'm gonna move my 3x this way. And I'm gonna put this plus 3 this way. That would cancel this and that would cancel this. So now I'm left with -2x is greater than or equal to 39. Then I divide by -2, divide by -2. What happens when I divide by a negative? The sign must flip. So then 39 divided by 2 is what, like 19.5? Yes, -19.5. Okay, so far so good. Oh, so here's probably the set of problems that we haven't really gone over, but I mean, don't overthink them. Really, guys, don't overthink them. They're not so bad. We're still applying the same rules. So we're trying to get x by itself, right? So how do let's just look at this part. How do I get rid of a +5? Well, I have to -5. But usually we do it, we say, well, what you do to one side, you do to the other. But in this case, we actually have three sides because it's a three-part inequality. So what you're going to end up doing is doing this. You're going to say negative 2 minus 5, 5 minus 5, and 20 minus 5. Because I want to get this 5 out of here. So now I did. So now this becomes negative 7, and this becomes 15. Well, then how do I get rid of a times 3? Well, I divide by 3, right? But then I have to do it to all the numbers. So I just do it to all the numbers. So this becomes negative 7 over 3, and this becomes 5. And there you have it. Okay. Let's do another one right here. How do I get rid of this minus 5? Y plus 5, plus 5, plus 5. So I'm going to have negative 5 is greater than, is less than or equal to negative 5x is less than to 10. These cancel. Okay. How do I get rid of a times negative 5? I divide by negative. Now, guys, the rule stays the same. All right. So this becomes a 1. This becomes a negative 2. But since I divided by a negative, I have to flip the signs. I have to flip the signs. Okay. So don't overthink it, guys. These problems, very similar to what we've been doing. It's a lot of the same concepts of just keeping everything balanced, right? Adding, subtracting, multiplying, dividing. But we're just adding little things now. Where, we're carving out the fine details. So these problems are all very similar. So right here we had, it's kind of like saying we had two different equations in one equation. Very similar to this. We have two different equations all in the same equation, right? So you just solve it, guys. Okay? You just solve it and then you keep it going, right? So right here, we have this and we have this. Okay, sorry, you guys can't see. We have this negative 9x minus 1 is greater than 35. Negative 8x plus 6 is less than or equal to negative 2. You're just solving them. It's like literally it's just like having two problems in one. Okay, so let's solve this one first. Okay, what do? I add 1 to both sides. What do? Divide by negative 9. Because I divided by negative 9, the sign flips. Okay, but I'm not done. That's not my answer. Because I have a second part. And because I have the second part, I have to do another. It's literally just doing two problems in one. Okay, so now we have this. Then we divide. But when we divide it by negative, so the sign flips. So the key thing right here, guys, is that we got to bring down this or. Okay, we got to bring down this or. Because what's going to happen is they're going to ask you to graph this. So how would I graph this? I know that x is less than negative 4. So I'm going to put negative 4 right here. Whoops. Negative 4. Let me redo that. This little hash mark is negative 4. Okay. I also know x is going to be greater than 1. So right here, less than negative 4. So that means it's an open circle. Less than, is that going to be to the left or to the right? Less than would be to the left. So then I shade to the left. X is greater than or equal to 1. So that means at 1, I have to shade in this one because it's equal to. And it says greater, so that means to the right. And there we go. So number 4 is the same concept. So we solve it. So let's solve it. We subtract a to both sides. divide by negative 8, divide by negative 8. Because I divided by a negative, I flip the sign. But I'm not done yet. I still got to do the second part. So plus 2 plus 2. That's a negative 14, guys, just FYI. So now we have negative 3x is less than or equal to negative 12. Divide by negative 3, divide by negative 3. X, we have to flip the sign, is 4. Now remember, we have to bring down this or. Okay, we have to bring that down. Okay, so if we was to graph this, we are saying that x is less than or equal to 2. So 2. Equal means I have to shade it in. Less than, less means to the left. Or x is greater than x is greater than or equal to 4. So we put it at 4. Equal to means we shade it in. Greater than means to the right. Okay. So I don't know if on the homework you're gonna get specifically just asked to do the math, or if you're gonna be asked to do the math and the graph. So I'm just kind of doing a little bit of both. So, but the most important thing is to be careful with the shading. Okay, guys, the shading is gonna be very very important. Okay. All right. So now we already done this before. We already did absolute values, but we never did it with an inequality. So the concept still kind of remains the same, just a little bit of minor tweaks. So last time we did this, we said that we have to change this from we need to have the positive and the negative. The only thing that changes from that is when we change it from the positive to negative, we also have to flip the sign. So this sign has to flip. Okay. So we do the same process. Add 4, add 4, divide by 7, divide by 7. So we get one part. Add 4, add 4, divide by 7, divide by 7. And there you have it. Okay. We have one of those one of those x is less than 9 or x is greater than negative 55 over 7, right? And we could graph it. Okay. Um, however, I'm not going to ask you to graph that right here on the notes. I want you to get this concept of this being flipped and remembering that we have to change this. So like right here, we would have it regular and then we have to change it. So we flip the sign and make it negative. Okay, so that's kind of like what I want you guys to remember out of this. Because if you get this part, the graphing comes easy. Like that's just second nature to you guys. All right. So right here, x will be less than 13 and x will be greater than 2. So that's kind of like if we was to graph it, it would look something like this. So we would have 2, we have 13, x is equal to 13 or less, and x is equal to 2 or less. So it'd just be like this in between, something like that. Okay. So here we go. Last two problems. So here, what we want to do is we kind of want to move everything away. Okay, so this becomes what, 4? Not 4, 6. So what's going on with me? And then you divide by 5, divide by 5. Okay. So now we have this. Now we could do our two equations. Okay. So now we would go x plus 7 is greater than 6 over 5. And we do x plus 7 flip the sign, 6 over 5. Oh, sorry, negative. Did I forget the negative over here? No, right? No, I made the negative 5. Okay, so negative right there. So minus 6, oh, sorry, minus 7, minus 7. So this would be 6 over 5 minus 35 over 5. And the reason why I put 35 because 7 times 5 is 35. So how many 5s go into 7? I mean, how many 5s go into 35? 7. So this is equivalent to 7. So we have x is greater than negative 29 over 5 minus 7 minus 7. So this would be negative 35 over 5. X is less than negative 41 over 5. And then again, that's going to be something that's going to look like in between two numbers. Okay. All right. Let's do another one over here. Let's first subtract 3. So now we have 4, 2x plus 6. Subtract 3 would be 16. Divide by 4, divide by 4. And then this is 4. Oh, these are nice. This one over here had fractions. This was nice. Okay, so now we set it up. We set up our two different ones. So we set up one regular, and then we set up by flipping the sign and making it negative 4. And then we solve. So the algebra is pretty much consistent. Like we're consistently doing the same algebra over and over again, right? It's just adding these new little steps here and there. Now get it, right here, we do not flip the sign. Just because this was negative 2, I did not divide by negative. Okay, so I don't flip the sign. So it just becomes a negative 1. Okay, we get that. Divide by 2, divide by 2. X is greater than negative 5. Again, you guys could also graph these, right? More than likely, they're going to be in between two numbers. So like x is less than negative 1, x is greater than negative 5. So that's going to be something like negative 5's here, negative 1's here. X is greater than negative 5, so that means it's going this way. X is less than negative 1, so it'll be in between, right? And we're shading everything in because they're equal to, right? Now, I'm not too sure if the homework's going to ask you to graph a lot of them. I'm pretty sure they're just going to ask you for this, okay? They're just going to ask you for this. I'm more than sure of that. Just be careful on the symbols, okay? On the notations, because you will have answer choices. They will all look the same. The only difference is they might give you uh, this symbol instead of this symbol, and so on and so forth, right? With the greater than. So just be careful, be cognizant, watch what you're doing. All right, don't get too eager in answering the questions. I know a lot of these problems don't seem that hard, right? You guys are pros at this type of stuff. Just be careful with this. Like these little symbols is what gets us, okay? And remember, a lot of them have two, so you have to check both, okay? All right, that's it. So don't forget to watch the videos, write your notes, and do your video assignment and your homework assignment.